what do we have to do here first? We have to factor. Okay, so just rewriting the numerator, 5x squared plus 20x plus 6. Okay, what do I need to factor out of the denominator first? An x. What's left? There you go. And then rewriting, it keeps factoring, doesn't it? You factor it all the way. So x times, how does x squared plus 2x plus 1 factor? X plus 1 quantity squared. And then also in this same step, we set up the decomposition. So here's where it changes a little bit. You have to consider the fact. Now remember what partial fraction decomposition really is. It's really undoing the addition of rational functions. So what disappears when you add rational functions together is any denominator of the same base but lower power of one of the other denominators. So you have to take into consideration this. Okay, first of all, you have a non-repeated factor of x. So you could set up, as before, just a over x. That's just nothing new there, okay? But what changes is you have to take into consideration the fact that you could have a denominator, a term, with the denominator of x plus 1 in the decomposition. Just x plus 1 to the first power, just x plus 1. Because if you were to add those together, that term would be engulfed by the common denominator. So you have to set it up like this. B over x plus 1 to the first power. It's possible b is 0. So it's possible that term isn't really there, right? That it's just 0, in other words. But we don't know that. And then, of course, in a decomposition, if it decomposes all the way, it has to have a term with a denominator of x plus 1 squared. So we'll say c over x plus 1 quantity squared. And even though x plus 1 quantity squared is technically quadratic, right, because when you multiply it out, it's degree 2, we don't think of it that way. We think of it as a repeated linear factor. And in any repeated linear factor, you can show that in the decomposition, the numerator is going to be, if it's a repeated linear factor, the numerator is going to be a constant factor, 1 degree less. Okay. Now, a couple things I haven't mentioned. You have to make sure this is a proper fraction. But if you were to multiply out the left-hand side's denominator, you'd get a degree 3 polynomial, wouldn't you? Whereas the numerator is degree 2, so you're okay there. And you have to make sure that if it's simplified all the way. So if the numerator factor to contain one of the factors of the denominator, you'd want to simplify it, cross out, cancel out one of those factors. So it's got to be in simplified form as well. All right. So any questions about that setup? Let me ask you guys. I'm not going to do this, but what if it were x plus 1 to the third power instead? Then you would have all this and more. What else would you have? You'd have another term, d over x plus 1 cubed. And so you would have a term, whatever that power on x plus 1 is, you would have a term for each power less than that. Does that make sense? Because when you find a common denominator, which is the left-hand side, x times x plus 1 to whatever power, all the other powers of x plus 1 get engulfed by that common denominator when you put them in terms of the common denominator, and they disappear when you do the addition. So you have to take into account that they could be there when you decompose it in the original sum. Are they there? No, it could be that c is 0. We don't know. But you have to look at that possibility. All right, so I changed the problem. Remember, it was originally 2, which is enough to get the idea. Okay. So that would be what I called step 1, I guess. Setting up the decomposition, make sure you factor the denominator. Step 2, what did I say to do? Multiply by the denominator and the left side. Yeah, clear out all the fractions by multiplying through by the LCD, which is going to be the denominator on the left side. So if you multiply both sides by the LCD, you'll always just end up on the left side with the numerator, in this case 5x squared plus 20x plus 6. What's left from the a over x when the x's disappear from the common denominator? So, if you need to see it, write it down. Okay, so I'm multiplying through by x times x plus 1 quantity squared. So think of the way it works algebraically is this guy gets distributed to each numerator over here. So what's going to be left when the smoke settles from the first term? A times x plus 1 quantity squared plus b times well, there will be an x plus 1. Oh, I see. You're going too. I can't think that fast. You're going too far ahead of me. So how about just x times x plus 1? Okay. And then what's going to be left from the third term? Just cx. Yep. Very good. Now, you multiplied that out, and if you were doing the full methods, all the steps, you would do that, but I'm not going to do that here. I wanted to leave it in factored form because I'm going to use shortcuts to find a, b, and c, which will be a lot faster than setting up a system of equations. So I'm going to stop here and use the shortcut. All right, so what would be a good value to let x equal? 0 is a good one, sure. What do we get on the left-hand side if x equals 0? 6. What do we get on the right-hand side if x equals 0? So we get just a times 1 squared, or just a. Well, that was a pretty good shortcut, wasn't it? All right. What's another value we could let x equal? Okay, -1. So by the way, we're going to use this. This is telling us a equals 6, right? So okay, if x equals -1, a little bit more work here, then that gives us what? 5, minus 20 plus 6 on the left side? And then on the right side, what does it give us? If x equals -1, you're plugging in -1 there, there, and there, and there. So what happens to the first two terms when we plug in -1? 0, 0 plus 0. And then the last one becomes, so minus c. So what does that end up being? So 5 minus 20 is what? -15 plus 6, -9 equals -c, or c equals 9. Okay, so now you're thinking, uh-oh, I've run out of things I can plug in and get x to be 0. What's the next easiest number to work with? 1. Let's plug in x equals 1. So I'd like to see if I can fit all this in across. So let me move this. Okay. So next, let's plug in, you can plug in any real number you want, but x equals 1 is a nice one to plug in. And I'm thinking there's no way I'm going to be able to fit that in there. That was a fool's errand. Oh, you know what? There is a way. How's that? Can't do that on paper. Okay, how about, so now I can fit it in. How about x equals 1? Okay, so on the left-hand side, that gives me what? If x equals 1? 5 plus 20 plus 6? 31? Everybody agree with that? That's the left-hand side. On the right-hand side, what do I get? A times four, or 4a. Everybody buy that? Plus, help me out here. I'm too tired to think. Plug in 1, I get b times 2, so 2b. I plug in 1 here, I get c. All right, I suppose technically I still have a system of equations, but is this going to be very hard to solve? I already know from the first part of the shortcut, I already know that a is 6 and c is 9. So I can get b, right? All right, so I get 31 equals 4 times 6, 24. So just plugging in 6 right there and then 9 right there, right? So plus 2b plus 9. Okay. So then what do I get? I get 2b. If I turn it around, I'm going to leave 2b and then, okay, 20. What's 24 plus 9? 33. Subtract 33. Negative 2. So I get b is equal to negative 1. So that's a pretty good shortcut, you guys. It would take you probably twice as long to do this problem if you tried to do it all by hand. I mean, I suppose you could get a system of equations, plug it in your calculator, and get the answer that way too. But that was pretty quick. Okay, so then what do? We fill in the decomposition, right? So it was a over x. What was a? Let me go 90%. So fill in the decomposition. And yeah, I was trying to fit all this in one view so you could see it all. Let me go 75%. Okay, I think we can see that. Okay, so what do we get? You guys fill it in for me. What's the decomposition? I'll do it over here. Yeah, so focus your eyes on this guy. Oh yeah, so a is 6. So 6 over x plus, what was b again? Negative 1 over x plus 1. Yeah, you could make that minus 1 over x plus 1 if you want. And then plus what? C, which is what, 9? 9 over x plus 1 quantity squared. So I'm just going to circle that. That's my answer.